Welcome back to my channel. This is part 4 of the climate series. In part 1 we talked about the difference between weather and climate and what are the factors that determine the weather conditions of a place. In part 2 we talked about India and what are the factors that determine the weather conditions of India. In part 3 we briefly talked about the Indian monsoons and the Arabian Sea and Bay of Bengal branches of the Indian monsoon and how India gets rainfall from it. This is part 4, according to me, the most important part, which is called the causes for monsoons or the factors that determine the reversal of seasonal winds in the subcontinent. Part 5 would be about seasons. If you have any doubt, put it in the comment section. I will get back to it. Starting with point number A, which is differential heating and cooling of land and water. So as you know, both land and sea get heated up and get cooled down also, but because the land has lower heat capacity as compared to water which has high heat capacity, the changes in land is abrupt, which means that land heats up quickly and also cools down quickly, unlike the sea, which takes time and is more stable. So what happens when the land basically heats up very quickly? So the air above it expands, rises up and expands, and when it expands it creates a low pressure belt. Always remember, when it is too hot, the air will rise up and it will expand and create a low pressure system. And when there is a low pressure system, the nearby high pressure system would rush in with their wind to fill up the low pressure area. So suppose there's a low pressure area over here, wind might come from here, from here, from here, wherever there is high pressure relatively. But again, wind follows a basically pattern in the eastern form or in the western form, so accordingly it would come into the land surface. So when wind flows from land to the sea in the form of land breeze, basically those are dry winds, because in land there is very less moisture. But when the wind system comes from the sea to the land, they usually carry a lot of moisture in them. So when they enter into the land area, they still have moisture and they try to absorb moisture, but after a point of time they cannot retain any more moisture within them and they shed down all the moisture in the form of rainfall. So differential heating and cooling of land lot of the times brings about moisture laden wind from the sea to the land, leading to rainfall. And because it follows the wind's path, it brings rainfall as per the wind's direction. Okay, I think this was clear. Second, and the most important point over here, is the shift of the position of the interconvergence zone or the intertropical convergence zone. This is a very important point which I will show you in this diagram. I think you have to be very careful over here, because this is a very important portion. So consider this as your earth, okay, and suppose this side there is the sun. This is the equator, right? So if here there is the equator, then obviously there is direct sunrise that this entire part gets, right? So if there is direct sunrise, what will happen? The air above the land will heat up, rise and expand. So it means this area basically is a low pressure area. So this area is known as the equatorial low pressure belt, ELPB. Now this area is also called the ITCZ, which is the intertropical convergence zone. Now ELPB, we understood why it is called equatorial low pressure belt, because over here there is low pressure, right, and it is in the equatorial part, so equatorial low pressure belt. So why is this called ITCZ? Because intertropical convergence zone, which means that the other winds come and converge in this zone. So how this convergence happens? So as there is a low pressure here, obviously the high pressure area over here would send out their winds immediately, and from here the winds will come in the northeastern direction. So basically these are easterly winds, but as we talked about the Coriolis force, they kind of change the direction, and this is the northeast winds, and this side you have the southeast trade winds. India falls basically in this zone. We always have the northeast trade winds, unlike the monsoonal conditions. Like when there is monsoonal conditions, there is a reversal. So yeah, so this is the low pressure, this is the high pressure. Wind flows from high pressure to low pressure. So what happens during summer is, because there is direct sun rays in this part of this earth, this ITCZ moves northward. So when this ITCZ moves northward, it just means that it carries the low pressure also with itself towards the north. So the point over here, we are talking about the shift of the position of the ITCZ. So this ITCZ basically shift northwards and somewhere comes at this position, and it brings a low pressure type of condition in the Indian subcontinent. So as we discussed, if there is low pressure, the temperature will rise, air will expand, then the wind system from the high pressure areas will come and fill in its place. So the first low pressure system we talked was by the differential heating and cooling of land. The second is by the shift of the position of the ITCZ, which moves northwards. That means it carries this winds along with it also. So this entire thing shifts northward, and hence a low pressure belt, which was initially created over here, which is below India, is now created near India, right? If you want a detailed explanation of the pressure belt system, that how this is low pressure, this is low pressure, this is high pressure, and the Walker cell and everything about this thing, do let me know in the comment section. I will make a separate video about it. Okay, so the first condition we did, second condition we did. Now the third is high pressure area east of Madagascar. So let us go to the world map. Okay, so this you can see is, wait, let me zoom in, there's some problem. Okay, this area is the Madagascar. So this area over here as a high pressure system running at that point of time, or during the monsoonal or the pre-monsoonal phase. So when there is high pressure over here and there is low pressure over here, so obviously the winds from this place will come down to this place. So this place and the high pressure in this place plays a very important role in getting the wind system over here. So just imagine if this was a low pressure area, then perhaps the wind would have come here directly, because winds always travel to the areas where there is low pressure to fill in the space. But because it is high pressure area and there are low pressure conditions in the Indian part, wind travels from here to here. Okay, so I hope this point was also clear. High pressure area east of Madagascar. Then the Tibetan plateau gets intensely heated during summer and formation of low pressure over the plateau. Okay, let's go back to the map again. So we saw that how east of Madagascar there is a high pressure belt which plays a very important role. Now coming to India. Okay, so in India, if you see, I think there's some zooming problem, but okay, you can just take out your map and see. Over here there is India, there is Tibet over here. Tibet, as you know, this land region over here gets heated up a lot, right? They get the direct rays from the sun and they get heated up, and because of the excessive heat there is a low pressure belt created over here. So that means there is low pressure from every direction, that is creating an ideal condition for the wind system to basically flow to the Indian subcontinent against the normal path. Then point number E is the movement of westerly jet stream to the north of the Himalayas and the presence of the tropical easterly jet stream over the Indian peninsula during summer. So The westerly jet stream, moves north of the Himalayas, it gets rainfall over there, and the easterly jet stream basically is in the peninsular part during the summer, and that gets rainfall in the peninsular part. Jet streams, I think we have covered in one of the portions. If you have still doubt, I can make a separate video about that. Then changes in pressure conditions over southern oceans or southern oscillation. Now this is a very important part, so let's see what happens over here. So usually, southern ocean conditions, we are talking about Indian Ocean and the Pacific Ocean. So usually what happens, this area is the low pressure area, and this area, if you see Australia, if you travel this side, then you will reach near Peru, right? Southern America. This area is the high pressure area, but sometimes this gets reversed and this area becomes the high pressure area, and it plays a very important role. And because the conditions oscillate between Indian Ocean and Pacific Ocean, and create disturbances throughout the world, this is known as southern oscillation. Another important point that needs to be discussed over here is El Nino, and later we will see that how El Nino plus this southern oscillation between the high pressure and the low pressure areas of the southern oceans, that is the Pacific Ocean and Indian Ocean in this context, lead to a condition called the ENSO. El Nino say N and southern oscillation say SO, ENSO, which impacts the entire world. These 2 or 3 points I will deal together now. So let us see what happens over here. So this is Australia, this is America, okay, South America. So this is basically the eastern side of the Pacific Ocean, and this is basically the western side of the Pacific Ocean. So the wind over here system basically moves in this direction. So it means, so imagine, suppose here there is America, because if I take from here to here, it might be confusing. So this is Australia. So suppose here somewhere there is South America, okay, somewhere here there is South America. So basically, usually what happens is, in South American, the eastern or the western coast of South America, usually there is high pressure, and over here there is low pressure. So what happens, because of the easterly and upwelling, lot of the warm waters from the southern part travel and reach the eastern coast of Australia. So this warm water, when it reaches over here, it creates low pressure system and brings about rainfall. Now when this place gets rainfall, all these places also get rainfall. So this is the normal condition. So in the normal condition, what happens, the warm water from the from the western part of South America or the eastern part of the Pacific Ocean through the easterlies travels by the process of upwelling and the trade winds to the basically this part of Australia, and over here they create rainfall, right? This is the normal condition. So suppose this condition intensifies, that means there's lot of trade winds, there is strong easterly winds blowing, and there's lot of low pressure over here, there's lot of rainfall over here, which will result in lot of rainfall over in India, in Indonesia, in Malaysia. This is known as La Nina, which is nothing but the opposite of El Nino, and the intensification of the normal conditions. So when the normal condition intensifies, it is La Nina. So La Nina condition is basically helpful for our country and other countries. Yeah, there may be a lot of floods, but still it brings about lot of rainfall. Now the opposite condition is known as El Nino, which happens during the Christmas time. So in El Nino, what happens, so the warm water which has come from the Peruvian and the Bolivian coast, basically Chile coast and all, and gathered over here, something happens, and this warm water again goes back and accumulates over here. So this place which usually gets extreme cold climate because the warm water travels and the inside cold water fills in over here, creating high pressure, suddenly gets low pressure because the water from this part suddenly moves back to this part. Okay, so over here there is low pressure created. That means this part gets a lot of rainfall, which is beneficial for the forest, for agriculture, which it usually doesn't get. In El Nino condition it does get. But what happens here is, because there is no warm water, because there is weakening easterly winds, this area becomes dry. This does not get a low pressure impetus, it becomes dry, there is no rainfall, there is drought like conditions. So always remember, low pressure is good, it leads to rainfall. Without low pressure over here, or the warm water which comes over here and doesn't heat this place now has no rainfall. Now if this place has no rainfall and has drought like conditions, all these places will affect. So the question is El Nino good for India? No, extreme El Nino is not good for India because it brings about drought like conditions, which India does not want, because India is heavily dependent on monsoonal rainfall for agriculture. So if El Nino time occurs and El Nino severes, then it affects the monsoon. So we basically, yeah, and the southern oscillation and El Nino together form ENSO, and that is not a very good factor for Indian monsoon. So we covered all the points which, even if they do not directly create monsoonal rainfalls, but they create conditions for the monsoonal rainfall or the seasonal reversal of the trade wind to happen. So first we talked about the differential heating, then we talked about the shift of the position of the intertropical convergence zone, then we talked about high pressure area which is in east of Madagascar, then the low pressure created in Tibetan plateau, then movement of westerly jet stream to the north of the Himalayas and presence of tropical easterly jet stream over the Indian peninsula. Then the most important part that you should know is southern oscillation, El Nino and ENSO. So if we go back to the map of India over here, so you see normally over here the northeast trade winds blow. This northeast trade winds usually blow, but because this ITCZ moves upward, that means it brings in the southeast trade winds, and because of the Coriolis force, this southeast trade winds get deflected towards right hand side. It gets deflected towards right hand side and enter India as the southwest monsoon. So they should have gone like this, right, the southeast winds. But see, over here Madagascar is there, it is high pressure, it's driving the winds this side. Over here there is low pressure, here there is low pressure, here there is low pressure, so they are attracting. So the wind which would have gone like this, because of Coriolis force and all the low pressure which is created here and the high pressure which is created here, the wind which would have gone like this turns like this and enters the continent like this is southwest monsoon. I hope this section was useful for you and you are a little bit clearer on the ITCZ and northeast trade winds, southeast trade winds concept. I have tried my best, but still if there is any doubt, I would love to clear. And all the best for your exams, and do subscribe to my channel for regular updates. Thank you.